In section 3.2, we learned that when two parallel lines are cut by a transversal, there are special relationships between alternate interior, alternate exterior, corresponding, and consecutive interior angles. Today, we're going to look at what is needed in order to make lines parallel. So the converse of what we looked at in section 3.2. First, I'm going to do a Sketchpad demonstration for you. You're welcome to follow along with your own Sketchpad if you would like, or just listen and watch as I demonstrate a conjecture. First, I'm going to construct two lines that intersect at point A. Then, I'm going to construct a circle with point A as the center. Now I'm going to rename this point C and construct this point D. And I'm going to rename this point X. Now I'm going to create segment AC, which is the radius of my circle. And now I'm going to make another circle with that radius length and point B as the center. This time I'm going to construct the intersection point here and rename that point E. Now I'm going to make segment CD and construct another circle with center E and radius length CD. Now I'm going to construct the intersection point of these two circles and name that F. Finally, I'm going to draw a line through points B and F. Now I have a lot of things on my screen here, so I'm going to go ahead and hide some things that we don't need. All the circles and the segments that we made. And what we're left with are two lines and a transversal. What I created was angle EBF and angle CAD. These are a pair of corresponding angles, and I used all those circles so I could create them to be congruent. I will show you now. These angles are congruent, and they will stay so even if I move things around. So I started with a pair of congruent corresponding angles. And now I want you to look at these two lines. What do you think is true about those two lines? To me, they look like they might be parallel. I'm going to go ahead and measure their slope to see if that's true. And as you can see, the two lines have the same slope, which means that they are parallel. And once again, if I move things around, those lines stay parallel. So we can conclude that when I have a pair of congruent corresponding angles, I know that the two lines that make those congruent corresponding angles must be parallel. This is a postulate and is the converse of the corresponding angles postulate. Remember, the corresponding angles postulate said if two parallel lines are cut by a transversal, corresponding angles will be congruent. So there we know that the lines are parallel, and therefore the corresponding angles are congruent. In this converse, we know the corresponding angles are congruent. That's the given. We then conclude that the lines are parallel. This is a postulate to help us justify why we know lines must be parallel. We also have converses for all of the other theorems that we learned in 3.2. Once again, these say if alternate exterior angles are congruent, alternate interior angles are congruent, or consecutive interior angles are supplementary, that the lines must be parallel. Also, if I have two lines that are perpendicular to the same line, those must be parallel. This comes directly from the postulate we just learned. These corresponding angles are congruent if these two lines are perpendicular to this line, so they must be parallel. Now I have an activity for you. I want you to fill in all the reasons for this proof. Go ahead and stop the recording now. You will be using either the converses or the original postulates and theorems from section 3.2 in some of these. This proof will help you decide when to use the original postulates and theorems and when to use the converse. Okay, now I have another activity for you to do.